Hey everybody, welcome to your last lesson in Unit 1. You have reached the end. Today we're going to talk about some more complex equivalencies. Your aim today is that you can multiply binomials using either double distribution or an area model. I'm going to teach you both ways for how to do this, and you can choose which one works best for you. Now recall that a binomial is an expression with two terms. Okay, that's a binomial. Remember, bi means two. So let's read. We should now have a better ability to work with exponents based on our last lesson we did. In this lesson, we will continue to explore expressions that are equivalent, meaning the same, but look different. Something that's equivalent in real life but looks different is like your teachers. You have me, you have Ms. Vasquez, and you have Ms. Samaru. We are all equivalent in that we all teach math, but we all look very different. That's what we're going to talk about today in math, things that look different but really have the same value. We will be primarily sticking with linear expressions, those where x is only raised to the first power, and quadratic expressions. So linear and quadratic. A linear is something where it's x raised to the first power, and a quadratic is something where x is raised to the second power. Recall that two expressions are equivalent if they return equal values when values are substituted into them. Meaning if I plug in a number, two expressions are equivalent if they come out to the same number after plugging in. So let's take a look at exercise 1 to see what this means. There's a lot of words, and I think examples are a great way to explain the words. So exercise 1 says, consider the product x minus 2 times x plus 5. Okay, we're multiplying those two expressions. Now these are two binomials. X minus 2 is a binomial, and x plus 5 is a binomial. That's why we're saying multiply binomials. This is your one binomial, and that's your second binomial. You're multiplying them. This binomial, this multiplication, is equivalent to one of the expressions below. Determine which by substituting in two values of x to check. Okay, so here's your first expression it might be equivalent to, and here's your other one. And we're trying to figure out which one. Is it column 1 it's equivalent to, or is it column 2? Now you could make a guess based on how it looks, but what we're going to do instead is we're going to plug in these values and see which ones come out to be the same. So you are plugging values. So for the first one, I'm plugging in x equals 3. So instead of x minus 2, I'm going to have 3 minus 2 times 3 plus 5. I'm going to plug this in. 3 minus 2 is 1. 3 plus 5 is 8. So I get a value of 8. Let's plug it into the second column. Instead of x squared, I'm going to have 3 squared minus 10. And I always plug in with parentheses when I have exponents. 3 squared is 9, and 9 minus 10 is negative 1. So it's looking like already these two aren't equivalent, because when I plugged it into the first one I got 8, and I plugged in the second one I got negative 1. So I'm guessing it must be equal to the last column. Let's check. Let's plug in 3 squared plus 3 times 3 minus 10. Follow PEMDAS. Let's do our exponents first. 3 squared is 9. I took out the parentheses. 3 times 3 again is 9. 9 plus 9 is 18. And then I'm continuing to carry down this minus 10. And finally I get 18 minus 10 is 8. And look, it is a match for the first one. So I'm thinking that x minus 2 times x plus 5 is equivalent to that expression right there, not this one. But let's try it with a second value just to be sure, and I'd like you to try it this time on your own. So please pause the video and try plugging in x minus 5 on your own. Alright, welcome back. Take a look at my work. You should again see that column 1 is equivalent to column 3. And let's write this out so we can see exactly what this is telling us. So this is saying that the binomial product, x minus 2 times x plus 5, is the same as x squared plus 3x minus 10. Now what's interesting about this is that when you look at x minus 2 times x plus 5, you kind of think about this right here, x squared minus 10. Because you think, oh, x times x is x squared, 2 times 5 is negative 2 times 5 is negative 10. So where are we getting this 3x? Well, that is the goal of this lesson, is to get you to understand where we're getting this 3x when we have to do something like multiplying binomials. So, let's take a look at how you could figure this out on your own. Exercise 2. Find the product of x plus 3 times x plus 5 by distributing twice. So, this is double distribution, okay, distributing twice. So, what we're going to do is we've got two distributions. Your first one, actually going to do it in purple. Your first one is looking at this x. You distribute it to that x, and you distribute it to the 5. This is your first distribution. So you have x times x plus x times 5. That's your first distribution. Your second distribution is the 3. You have to distribute the 3 to each of these. This is a distributive property, you're just doing it twice. So this is your second distribution. And you just tack it along. So this becomes plus 3 times x plus 3 times 5. That's your double distribution. Now we go through this problem and we simplify. So I'm going to say x times x is x squared, plus x times 5 is 5x, you always put the number in front, plus 3 times x is 3x, plus 3 times 5 is 15. Finally, I have to look for my like terms. I see that 5x and 3x can be combined, and when I combine like terms, I add their coefficients. So I'm going to do 5 plus 3 and get 8x, and then carry the 15. And I have successfully turned my multiplying binomials into a trinomial. A couple things you have to think about here. 1, be careful with your signs. Now, we only had addition in this problem, so we don't have to watch out for that. But in the future, when you have negative symbols, you have to be really, really careful with this. I always draw my distribution lines. See how I drew the first and then I did the second? That really helps me remember what all I'm distributing. There's another way I want to show you, and this other way is called an area model. Okay, now again, you can always pause this, go back, rewrite. You do not have to just keep going with me if you have questions. You can always pause, rewind, and recopy. So let's take a look at this problem again. Again, it's the same problem, x plus 3 times x plus 5, but I'm going to show you a different way, called an area model. The area model is going to ask you, you're going to have to draw a box, looks like this. You're like finding your area of a rectangle. I'm going to put the x plus 3 on the top. Actually, I'm going to do it in a different color. Let's keep the purple and the red. I like that. So I'm going to put the x plus 3 on top. I'm getting the x plus 3 from here. And on the side, I'm going to put the x plus 5. Okay? Now I'm going to find the individual things that go in the boxes. So in the first box, I'm going to look at the x and the x. So x times x is x squared. Then I'm going to go to the right box. Then I'm going to do 3 times x and get 3x. Bottom left box is going to be 5 times x, 5x. And the final box is going to be 3 times 5, which is 15. The area model is really nice because it helps keep your work organized. I'm not done because, again, I need to make my answer look like this, the first answer, right? So I'm going to take each of these terms that I've found and write them out. I'm going to add them all together. So plus 3x, plus 5x, plus 15. Notice I got the same thing here as I got here when I did double distribution. The exact same thing, I'm just modeling it in a different way. I have to simplify still, so I get x squared plus 8x plus 15. Okay. Now this area model will work for any time you're multiplying two binomials. Any time at all. Draw your box, put one of your binomials on top, the other one on the side, and do your 4 multiplication problems. Okay? So let's do some examples together. I think that we need some practice with this, so I'm going to do 3 examples here, and then you're going to try 3 on your own. Okay? So let's try A together, and I'm going to solve A using both ways. I'm going to do both so I can show you. First, let's do double distribution on A. So here's my first distribution. is going to be x times x plus x times 3. My second distribution is going to be with the 6 to the x and 6 to the 3. So I have plus 6 times x plus 6 times 3. Now I combine them all, simplify. X times x is x squared, x times 3 is 3x, 6 times x is 6x, and for some reason my pen has stopped working. I'm not sure why. There we go. And then plus 6 times 3, which is 18. I'm going to have those like terms again, the 3x and the 6x, and I can combine that into 6 plus 3, which is 9x. Carry down the 18. Put a box around my answer. That's double distribution. Now let's say I want to solve this using an area model. Okay, so I'm going to draw a box. There's my box. On top, I'm going to put the x plus 6, and on the side, I'm going to put x plus 3. And now I'm going to find all the individual problems. So this first one is x times x squared. The one on the right is 6 times x, so 6x. This bottom left is 3 times x, so 3x. And this is 6 times 3, which is 18. Now I have to add them all up, so I get x squared plus 6x plus 3x plus 18. I'm going to write a little note here that says don't forget to add all terms up. Then I have to combine like terms. I see a 6x and a 3x, which gives me 9x. And again, notice I got the exact same answer I got when I did double distribution when I used the area model. Okay? Again, I don't care which way you do it. Students tend to find the area model much easier, but I want to show you both so you can see that there are multiple ways to solve a problem. Okay? All right, let's try letter E together. I'm going to skip to E. Okay, so let's skip to E and extend the page. So here is letter E, and again, if you want to go back to letter A, you can always rewind and in the video. So I'm going to show with double distribution, because what's different about E? E now suddenly has coefficients in front of the x terms. It's the only thing different about E, and we have a negative sign. So I'm going to start off with double distribution. There's my first one. So I have 3x times 3x plus 3x times 2. Now I need to do my second distribution, which is the negative 4. So I'm going to have plus negative 4 times 3x plus negative 4 times 2. Double distribution. Now we simplify, and here's where we have to be very, very careful and pay very close attention to our work. 3x times 3x, well, first do the 3 times 3 and get 9, and then x times x is x squared. Second term, 3x times 2, we just multiply the 2 times the 3 and get 6x. Keep going, we're going to have plus negative 4 times 3x is a negative 12x, plus negative 4 times 2 is a negative 8. Now here's where we have some negatives, so I have to be very careful. 9x squared doesn't have any like terms, but 6x and negative 12x are like terms. Okay? So 6x plus negative 12x, you can do that in your calculator by putting in 6 plus negative 12. You will get negative 6x when you combine these. And then carry down your plus negative 8. However, we don't write a plus and a minus sign next to each other, so we're just going to keep the minus sign. Okay, now I think double distribution is much harder for this kind of problem. And you're going to see why when I show you the area model. I think you'll think the area model is much easier. So let's draw my area model. Draw my box. What goes on top? The 3x minus 4. And remember, keep your signs. Keep your signs. It's really important. On the left is 3x plus 2. Now we multiply. What goes in the first box? 3x times 3x. That gives me 9x squared. Let me rewrite that just a little nicer. 9x squared. Negative 4 times 3x is negative 12x. 3x times 2 is 6x. And negative 4 times 2 is negative 8. Now I have to remember to add them up. So it's going to be equal to 9x squared plus negative 12x plus 6x plus negative 8. Again, notice it's the same here as it is up here. You've just created a different model. I still have to combine my like terms. I'm going to underline them. 9x squared, negative 12x plus 6x, negative 12 plus 6 is negative 6. And I'm going to bring down my plus negative 8. Okay. Alright, I'd like you to try the other 4 on your own. So pause the video, please pause, try them on your own, and then when you unpause you can come check your work. Okay? Good luck. Okay, welcome back. That probably took you some time. I hope it did. It should have taken you at least 4 or 5 minutes per problem. So let's take a look and see what you got correct. Letter B, your correct answer should be x squared plus 2x minus 24. A couple things on B to be careful about is combining the 6x and the negative 4x. 6 minus 4 is positive 2, and 6 times negative 4 is negative 24. So watch your signs. I've done both double distribution and the area model for letter B to show you both ways. Letter C, I only did the area model. I'd really like you guys getting in the habit of the area model. I think it's really useful and it helps keep track of your signs. And letter C had some tricky signs. You should have gotten a negative 3x and a negative 3x when you multiplied. Carried those down, negative 3 and negative 3 combined into a negative 6. So be really careful here when you added them, you got that negative 6. Use your calculator. In your calculator, you would just plug that in as negative 3 plus negative 3. That gives you a negative 6. Okay? Use your calculator. And then a negative 3 times negative 3 is a positive 9. Okay? Letter D was a lot nicer because it was just addition. You should have gotten 6x squared plus 18x plus 3. Oh, wait, nope, I made a mistake. I'm sorry, this should be plus 2x plus 9x. You should get a plus 11x. Okay? 3x times 3 is 9x, 2x times 1 is 2x, and then you combine your like terms of 2x and 9x to get 11. 2 plus 9 is 11. Okay, and finally the toughest problem was letter F. It was tough for a couple reasons. It was tough because you had an invisible 1 you were multiplying, so you should have gotten 4x times x is 4x squared. Negative 1 times positive x is a negative 1x. And I wrote in the negative 1 just to help you out. You don't need to, but it's super helpful to write in those invisible 1s sometimes. 4 times negative 7 is negative 28x, and negative 1 times negative 7 is a positive 7. So when I combine all of these together, I get 4x squared minus 1x minus 28x plus 7. You could also say it's 4x squared plus negative 1x plus negative 28. But in your calculator, you should put it in as negative 1 plus negative 28, and you will get negative 29. That's where I got the negative 29x. Okay? If you have questions, which I imagine a lot of you do, that's what class time is for, that's what the website forums are for, that is what your teachers are for. So please get started on your fluency to get some good practice here, and you can check your answer keys online. Good luck.